Everyone, so this is the Unit 1A review. You have the printouts of these, but this is the official reviewing of the solutions, just to help you prepare for your progress check. So keep in mind the reviews do not cover all material from the lessons, but should give you key points. So this first one, I'm just going to go through these answers quickly because you should be able to do this on your own. And you should just really be checking the answers. So identify the dependent and independent variables is what I'm looking for in this first example. So in this first example, the dependent variable is the number of people swimming because that amount of people will affect the temperature, or the temperature affects the amount of people who are going into the water. So remember, the independent is on its own, temperature is on its own, and the dependent relies on the independent. So however many people are in the pool depends on how warm or the water is. So in section 2, or question 2, let the function f be increasing or decreasing, but not both. State whether the function is increasing or decreasing on the interval 9 through 17. So on this whole little chart, I'm basically looking to see whether my function is increasing or decreasing. It cannot be both. So if I am looking, my 9, 11, 13, 15, 17, all of my x values are increasing. And then because they are all increasing and my y values are increasing, so 8, 12, 15, 17, and 18, because they are both increasing, this graph is increasing on this interval. Okay, now I'm going to use the graph to the right to answer the questions below. On what interval or intervals is the graph concave up? So remember, that's when your graph is open upwards. So it's really only open upwards at one point, and that is from your x needs to be greater than I. So what's happening here is I is kind of your turning point, and once you hit that point, this is the entire concave up until forever. Okay, so that's my concave up. And then when is it concave down? Well, I'm going to use that I again, because again, this is the turning point, and at this turning point, there's my concave down. So when x is less than I, that is when it is concave down. Now, on what intervals is it increasing? So now I'm looking for, when does my graph go up? Remember, you read your graph left to right. So here my graph is increasing all the way until it gets to h. So when x is less than h, the graph is increasing. And then when x is greater than k, k is my next point in which I am increasing. So x has to be greater than k. Okay, and then on when is it decreasing? Now it's decreasing this entire middle part, right? So from h all the way to k, x is going to be in the middle, and then I need to identify that x has to be greater than h, but less than k. All right, and then my zeros of the functions, that's where my y-intercept, or my y value is 0. So I have 3 key zeros, which is when x equals g, j, and l. They're a little hard to see. Let me go ahead and erase some of this. Okay, so here it was G, J, and L. Those are my zeros. And then my y-intercept is when y equals 0. So when x equals 0. So when y equals b, that is my y-intercept. Now this next question is calculator active, so you are able to use your calculator. And what you are going to do is you're going to find the rate of change of the function. Here's the function on the interval -5 to -1. So what you first want to do is actually calculate what r of -5 and r of -1 are. So when you plug in those values to wherever you see r, you get that r of -5 is square root of 21, and -1 is going to be the square root of 5. So I'm not going to work that out. You should know how to do that. So then you would end up with the square root of 5 minus the square root of 21 over -1 minus -5. Remember, two negatives become a positive. So it would be this square root over 4. I would want to do the square roots at the end, so that way you can just plug that into your calculator. And when you do that in your calculator, you get that the answer is about -0.5866. Now you should be close around this number. It also depends on where you rounded. So if you rounded at the beginning or if you rounded at the end, your answer might be a little bit different, but you should be in that ballpark, okay? Now, here is another calculator active. So this one is calculator active, and question 6 is also calculator active, and I believe those are the only calculator questions that you have to do. So using the information in the table below, find the average rate of change for each given interval and include the units. So basically all it's telling you to do is find the slope. Find the slope in 3 different scenarios. So at 135, my y value is 3.5. So, and then at 200, it is 0.3. So I would want to do, I'm going to do 200 in the denominator, the 200 minus 135, meaning I'm going to have that 0.3 minus 3.5, which is going to give me about -0.049 miles per second. Okay, and in the next one, again, it is going to be at 24, which is 8, and at 135, which is at 3.5, we already figured out. So let's do 3.5 minus 8 over 135 minus 24. Now you can have it in either order. It does not matter, just as long as your x value matches with your y value. So if your x, you're using 135 first, make sure that the corresponding y is first as well. So that, when I plug that in my calculator, is -0.0405 miles per second. And then in the last one, I'm looking at that 24, that 8 again, and 200 of 0.3. So 0.3 minus 8 over 200 minus 24. And that's just about -0.0437 miles per second. So again, your answers may be slightly off depending on where you rounded, but as long as you can get to the same answer whether you rounded or not, as long as you're in the similar area, you should be good, okay? And the last one, I'm going to estimate the rate of change of f of x equals x squared minus x at x equals -1. So what they're going to do, remember, so when it comes to estimating, you're going to use the -1 that they gave you, and then you're going to get as close as possible to that value. So I'm going to use -0.999. Okay, so when I do that, I'm going to do f of -0.999 minus f of -1. So remember, these are the y values. So the y value of -1 and the y value that corresponds with the -0.999, which I am going to use the calculator because this would require me to do that -0.0999 squared minus -0.999. So when I do that all in my calculator, my final answer should be about -2.999. So remember, this is an estimate. So you should be somewhere near that number, and that's what you are looking for. Now, number 7, Mr. Gardner is decreasing the amount of water used on the lawns each month, and the height of his grass is decreasing. Does this scenario represent a positive or negative rate of change? Now, this question is a bit confusing. We want to automatically say negative because it is decreasing. However, it's actually a positive rate of change. It's a positive rate of change because both uh, values are decreasing. You are decreasing the amount of water and your height is decreasing. So it's a common trend. It's happening for a reason. Okay, so that is why it is actually a positive rate of change. Now, questions 8 and 9. What is the average rate of change for each function on the given interval? So this is still slope. We are still doing slope. Once again, you want to find when x equals, so 7 minus 2 times 1 and 7 minus 2 times negative 4 to get your y values of 5 and 15. And then I'm going to do the slope, right? So 5 minus 15 over 1 minus negative 4, which gives me negative 10 over 5, so negative 2. All right, and really quickly, I'm going to do number 9 because I think we should all know how to do rate of change by now. And we end up with 3 over 3, which is just 1. Now, what is the rate of change of the average rate of change for each function over consecutive equal length intervals? So remember that in this situation, what you have to do is you have to calculate basically the differences, the successive differences that we talked about. Now, at 5x plus 9, there is not going to be a change, right? Your linear function has a constant slope. Okay, so there's no way to say an average rate of change or a rate of change of the average rates of change because there is no change. So what's happening is that the linear function always has a 0 for the average rate of change of the rates of change. The key point here is to remember that a linear function is more constant, right? So for example, here I have 2x minus 5x squared. I want to do f of negative 1, f of 0, f of 1, and f of 2, right? I want to have at least 4 points so I can determine if I'm going to have what I'm looking for. So when I plug all these in, I'm actually not going to do that. We should be able to figure out how to do this, right? We're in AP, so we just have to plug in the values, and we'll get that the first one is negative 7, 0 is 0, 1 is negative 3, and at 2 it is negative 16. So now I figure out my differences, right? So from 7 to 0, is plus 7. From 0 to negative 3 is a negative 3. And then from negative 3 to negative 16 is a negative 13. So nothing's happening there, no constant value. From plus 7 to negative 3, that is a negative 10. And from negative 3 to negative 13, that is a negative 10. So the rate of change is changing consistently by negative 10. So negative 10 is actually your answer for that question. So number 12. The values of a function are given at selected x intervals in the table below. The function concavity does not change. Determine the function is concave up or down, and then justify your answer. So first things first, I need to make sure that my x values are all evenly spaced. So from 5 to 9, that's 4. From 9 to 13 is 4. 13 to 17, 4, and the last one is also 4 as well. So everything is consistently changing by 4. All right. Now the next thing is I am going from 45 to 20. That is decreasing by 25. from 20 to 0 is minus 20. And then 0 to negative 10 is negative 10, and then negative 4. So my y values are decreasing, okay? So because my rate of change is increasing over the equal length, right? Because really what's happening is this is increasing, right? As I'm going from negative 25 to negative 20, that's a plus 5, plus 10, so on and so forth. So what's happening is my graph is actually concave up because the rate of change over equal length, so that's why we had to check that the x values were equal. So because it's an equal length and my rate of change is increasing because of that over that interval, then it is a concave up. So the next thing is finding the leading coefficient and the degree of each polynomial. So my leading coefficient, remember, you have to make sure that it is in standard form, meaning that your largest exponent is in the front. So here my coefficient is just 1 and my degree is 5. Now here I have to make sure that I'm looking at the largest exponent, which is over here, which is a degree of 3 with a leading coefficient of 7. Then the next ones are let f of x be a polynomial function with the given values. Are there any guaranteed extrema? If no, state where they occur. So what I want to do is I'm going to kind of sketch out a graph, right? So when x is 0, my y is negative 3. When x is 4, my y is 0. And when I have, so 4, 5, 6, 7, when x is 7, my y is also 0. Okay, so I'm now going to figure out if I have a guaranteed extrema. Well, remember that between two zeros, there exists an extrema. Whether it is a maximum or a minimum, that we don't know. But I can say that yes, there is an extrema between the values of 4 and 7, and x is going to be less than 7 but greater than 4, and that is where my extrema will lie. Now on this next one, I have at negative 7, ooh, it's a little short. So at negative 7, my y is 0. At negative 2, my y is 5. At 0, my y is 1. And at 9, my y is 0. So once again, I have between 2 points at 0, so I can say yes, there is one, and it would be on the interval between the two zeros, which would be negative 7 and 9. So somewhere when x is less than 9 but greater than negative 7, the extrema exists. Now, is there a global minimum or maximum for each of these functions? So what I want to do, remember to do this, is I need to figure out my degree, which is even. So my degree is even. My leading coefficient is negative, meaning that my graph opens down, right? So that means that it would have a maximum. Okay, now here I have an odd degree. Okay, and actually I can stop right there because if you remember, odd degrees do not have a global or absolute maximum or minimum. Okay, so they do not have one. So none. All right, so now find the following extrema. If there are none, cross it off and write none. So now I'm looking here at my graph. I have an absolute min, so an absolute minimum of blank when x equals blank. So I want to look for my lowest point on the graph, and there it is. So I have a minimum of 1 when x equals 4. Now an absolute maximum, I actually don't have an absolute maximum in this example, right? Because looking at this graph, I have one maximum, and that is it. There's nothing else. So there's no absolute maximum. Then I have a relative minimum at x equals -1. So here's one. And I've already identified the other minimum at x equals 4. So those are my two, right? And then a relative max, I do have one when x equals 1. So those are all the information that I needed from that question, from that graph. Now, for each polynomial function, find the intervals for each condition. So now they're saying, here's your graph. When are the y values less than or equal to 0? Okay, so the first thing I want to do is I want to find my factors of these functions, which I can easily do my shortcut. Remember, both will have an x. I keep the first sign, so negative, and a negative times a positive is a negative. And then two values of 15 that will combine to give me 8 are going to be 5 and 3. So I have x's at 5 and 3. Remember that they are always the opposite values. They will never be negatives like I have in the parentheses because I set them equal to 0. Now, this is where it's going to be a little tedious, and I'm not going to spend too much time doing that, but essentially what's going to happen is you need to figure out what's happening on the interval when negative infinity to 3, what's happening at 3, which we already know, 0, because these are the zeros of my functions. Then I have from 3 to 5, 5, which again is another 0, and then 5 to positive infinity. Now, what you have to do, and I'm not going to do it for you, I will just write in some little steps, is your step 1 is pick a point in the intervals. So if I'm looking for a value between negative infinity and 3, maybe I want to use 0 because that'll be easy to solve for, right? Between 3 and 5, well, there's only 4. And then from 5 to infinity, I'll just go ahead and settle with 6, right? You don't want to go too high of a number. You want to keep these values very simple. So you are going to solve for those values and then determine. So your step 2 will be determine the graph behavior. So when you plug in these values that I've given to you, if you haven't done this question yet, you can go ahead and fill it out if you want to with those red values there. When you plug it in, what's going to happen is from negative infinity to 3, it will be positive values. Between 3 and 5 will be negative, and 5 to infinity will be positive once again. Okay, so your function is negative. So when h of x is less than or equal to 0, so when it is including 0, right, meaning I'm now using brackets. So between 3 and 5 are my negative and infinite 0 values. My 0 and negative values are found between 3 and 5. Okay, and it's the same thing going on over here, except in this first example, I want to factor out a negative x so that I can have a positive x squared minus 5x minus 24. And then once again, I'll factor, and my factors in this example are going to be x is equal to 0, x is equal to -3, and x is equal to 8. If you have questions on how I got those 3 zeros, please feel free to ask me in class. We can go over that. So then you have f of x, and again, you're picking your intervals. So you're going from negative infinity to negative 3. We know what's happening at negative 3. It is a 0. From negative 3 to 0, at 0 is a 0. And then 0 to 8, what's happening at 8, and then what's happening, it's actually kind of cut off there, but we'll fill it in. So again, I'm going to pick the random points that I want. So between here, I'll go with negative 4. On here, I'll go with negative 1. I'll do 1, and then anything greater, I would want to do 9. So just so I can get those values, when I plug those back into the function, I end up with positive, negative, positive, that's a 0 as well, and then negative once more on the end. So when is my f of x greater than or equal to 0? Well, it's going to be from negative infinity to 3, and it's going out to negative 3, and it's going to include that negative 3 because remember, it's equal to 0 as well. And then I jump over till I get to 0 to 8. And both of those get brackets because both of those are included. So that is how you would figure out question 24. Now 25, the degree of a polynomial is 7 with real numbers at x equals negative 8, x equals 1, and x equals 4, and x equals negative 1 has a multiplicity of 3. How many non-real zeros does the polynomial have? Okay, so this means that I have x plus 8, x minus 1 cubed, and then x minus 4. So I'm going to write it out like this so I can visualize it, right? Because that's going to be a degree of 7. Okay, and then they tell me that I have 5 real zeros. So I'm given 1, 2, 3, 4, and 5. So I have real ones. I have 5. So what I want to do is I want to subtract 7 and 5 because that's going to give me how many is left over. So I will have 2 non-real zeros. Okay? And then question 26, 5 minus I is a non-real zero of a polynomial. Find another zero. So this is a very easy question as long as you remember that every complex number has a conjugate and they have to be included. So if you have 5 minus I, you are going to have 5 plus I as another zero. All right. And number 27, find the degree of the polynomial from the given input and output values. So this is, once again, successive differences. So to go from 2 to negative 2 is 4. From negative 2 to 4 is 6. 16, 26, 36, 46, and 56. So no constant values there. This is, remember, my first difference. So this would have worked if this was a linear function. But it is clearly not. So I'm going to try with another row. Here I have, oh, it's negative 4. So here I have 10, 10. So notice now I have a constant term in the second difference, meaning that this function has a degree of 2. Now the next two questions state whether the following graphs represent functions that are even, odd, or neither. So remember, even or odd functions what determines them is their symmetry. So this function here can be folded onto itself, so it is an even function. This one cannot. It's a mirror reflection, so it is an odd function. And that's all you had to do for those two questions there. Now, the last few, state if the following functions are even, odd, or neither. So remember, now I'm not given the graph, so now I kind of have to figure this out on my own. So remember that if it's an odd function, your f of negative x needs to equal negative f of x. And if it is an even function, the inverse of it should be the same as the original. Okay, so if I replace every single x with negative x, if this is even, I'll get the exact same function. If it is odd, then I will not get the same function. I will get the function if I multiplied everything by -1. So let's see if we can get this to work. And I should already realize that it's not going to be the same just because of this last term here, right? That last term is going to end up being a positive 2x. So there's no way I'm going to have an even function. I just need to see whether it is odd or whether it is neither. So here, when you have a negative value to a 7th power, you end up with a negative at the end of it. Okay? And then same thing here. I would keep that negative, so it would be negative 5x cubed, and then plus 2x. So now this is actually an odd function, because again, it's as if I multiplied this original by -1, and I get the values that I would have. So that makes it an odd function. Now again, for an even, when I replace that x with -1, it shouldn't change anything, or that with negative x, not -1. So this is going to be a positive, or an even exponent with a negative value is going to end up still being the exact same sign, or actually end up being a positive, which keeps the 6 at a negative. So 6x to the 8th, and then negative x squared would be a positive x, so it would stay negative 3x squared. So this is an even function. Okay, now I'm going to describe the end behavior of each function, and now I'm going to use limit notation. So remember that end behavior is determined by degree and your leading coefficient, whether it's going to be positive or negative. So in this example, my limit as x approaches negative infinity, p of x, I'm going to use p of x because that's what they give me, p of x equals, now this is an odd function, meaning it's going to look like a cubic one, but it has a -11, meaning that it's going to actually be flipped. So this is odd, this is negative. So rather than the regular, I'm going to actually flip it so that it looks like this. Meaning that as I am approaching negative infinity, my y is now approaching positive infinity. And the limit as x approaches positive infinity, p of x is approaching now the negatives. So negative infinity. Same thing happening over here. My degree is even this time, but my leading coefficient is still negative. So remember that a regular function that's going to be positive is going up, but since the leading coefficient is negative, I'm looking more at a downward. Now remember, every even degree function, the end behaviors point in the same direction. So the limit as x is approaching negative infinity, p of x approaches positive or negative infinity. and the limit as x is approaching positive infinity, p of x is also approaching negative infinity. And now this one is the graph. This one should be easy enough to read. So I'm going to call this one f of x. They didn't tell me a name. So as my x values are becoming negative, my y values are decreasing, so going towards negative infinity. And then my limit as x approaches positive infinity, f of x is approaching positive infinity. So again, as it's going over there, going up. Now I'm going to sketch the graph of a polynomial that could match statements that the limit as x is approaching negative infinity, my y's are positive infinity, and the limit as x is approaching positive infinity, y's are approaching positive infinity. So because both of these are in the same direction, I'm looking at any kind of even function. So you could do a quartic, you could do a parabola, either one of these is acceptable. Okay, and with that, that is the 1.A review.